Good afternoon, everyone. I'm Elizabeth, and this is Jean-Antoine
Hi.
from BiosensUM. The device we developed this year is called the BioSpectrum. So what distinguishes the BioSpectrum is the user-friendly technology, the validated bioassay, the analysis in under 4 minutes, and especially the custom app that acquires and processes data, as well as delivers the results from a cell phone. The minimal hardware that requires no electrical components, therefore you can use it anywhere. And finally, the adaptability for the detection of possible other antibodies as well. So to specifically detect adalimumab, we developed a surface plasmon resonance bioassay. We functionalize a gold-coated glass prism with a receptor composed of a short peptide linked to TNF-alpha, highly specific to adalimumab, as you all know. When the cell phone light passes through the glass prism and does total internal reflection, the perpendicular light wave will penetrate the gold layer, and the surface plasmons will absorb a specific wavelength dependent on the refractive index of the solution at the surface. The higher the concentration of adalimumab that binds to the TNF-alpha, the higher the refractive index, and the higher the wavelength absorbed. To perform the SPR bioassay, we developed a microfluidic chip that's disposable. And we integrate the gold-coated prism using an adhesive layer. I'm not sure how, okay. You can't really see, but the 20 microliter sample is injected in the input channel, and then suction is applied at the output channel using a plastic syringe to induce a controlled flow and recuperate the used sample at the end. We first validated our bioassay using a commercial SPR system and achieved good linearity, as you can see in blue in the first panel. And then we wanted to see if we could store functionalized chips for 24 hours prior to analysis. And we achieved, again, quite good linearity, which is a very promising result towards commercializing our sensor. And finally, we could transpose the bioassay using our own technology and got an R squared of 0.92, which was very encouraging. So now Jean-Antoine will
Yes.
talk to you.
All right. So now I guess you wonder, but how does it work? How can you do an SPR device without any electrical component? Well, the key is a cell phone. Why? Because a cell phone possesses two main parts of an SPR device, the light source and the detector. But apart these two parts, there's also the basic parts of an SPR device, such as collimator, optical fiber, and etc. But here, our device also possesses the microfluidic chip where the biochemical assay occurs, and the grating. And the grating is a key part of our device because it will split the light into multiple wavelengths. Then this rainbow that you will get will be shown on the camera, and you take the picture. So basically, our device is optical basic tool parts and the cell phone, the user cell phone. So the user can do his measurement wherever he wants. He only needs the device, the internet, and its cell phone. But speaking of the cell phone, with this, inside the cell phone, there's an application we developed by ourselves that is composed of an algorithm that will do the SPR detection. So, sorry, the user will do two measurements, the reference measurement and the sample measurements. These two pictures will be sent into a cloud where our algorithm will process the two pictures, and with an SPR basic calculation, you will get an SPR shift. But here our shift is a pixel shift, not a wavelength shift, which is different. So once you get the shift, the pixel shift, you do the interpolation inside again our data processing, which is in the cloud. And then the cloud will transfer the output concentration to the application where the user will have the result on the screen. So basically, I hope you see our device as great as we do. And I would like to thank our partner with whom the work would have been impossible. Thank you.
So, who has a question? Yes? Good.
Hi, good job. So I
Thank
really liked your approach of using the cell phone to solve this issue, and I do believe this is a good step for a point of care system. That being said, let me ask you a few questions.
Of course.
You mentioned that the prism needs to be passivated 10 minutes prior to usage. How do you
Initially,
see it
that
improving? Yeah.
well, we continued working on our sensor until the last possible second, but a lot of it had to be already shipped, or even our
Yeah.
presentation was already sent. Now, for the competition today, we only passivated for 30 seconds.
Oh.
Yeah, and
okay.
it works well.
Good job.
We hope.
So I have some additional questions. So you mentioned also that it's ingenious. You're looking at the shift in SPR. You mentioned that it's hard to visualize. I will imagine by naked eye. So
Yeah.
what was the strategy to compute or to calculate the concentrations given this limitation or visual limitation?
Yeah, so the eyes cannot see, like, inside a pixel, there's a decomposition into RGB matrix, and the eyes cannot see both polarization of light. So to do so, we use the reference spectrum and the sample spectrum. We decompose every spectrum into the R intensity of each pixel, and then you will see literally a shift, well, not a shift, but a decrease in intensity in the 2 pixel compared by both.
Mm-hmm. So
I'm not sure if I'm clear.
which type of image processing are you using? Just measuring intensities, or you
Yeah.
using something more sophisticated?
No, it's a basic intensity.
Good.
But the red intensity.
Yeah. So finally, you have shown us your calibration curves within the therapeutic range, 5 and 8 or 9 microgram per milliliter. You almost
Yeah.
lacking some points. In the meantime, you were able to
We did
produce a-
from 0.1 micrograms per milliliter to 10.
Yeah.
So it's even bigger than the dynamic
Yeah,
range from the competition.
You
Wait,
you can show.
Yeah.
So if you have some extra points between 5 and 10, it will be, I think, even better.
Oh,
because
you
it's-
mean to
you have
improve
the
that? Yes.
Therapeutic
Yes,
range.
we did
Yeah.
5 points.
Yeah.
Here, especially because when we were first developing the bioassay, we were waiting 20 minutes to reach equilibrium, which is clearly not the goal for this competition because we have to do it under 5 minutes. And so it would take me like doing the whole process would take me like almost 3 hours, even more, to do just that calibration. But then using our own system, we take the measurements after 3 minutes, and we did only 30 seconds of passivation, so all that brought it down to under 4 minutes, actually. Because after you take all the pictures, it takes the algorithm 25 seconds to process it, and then your result pops up on the screen.
Good job.
Thank you.
Thank you for a nice presentation and a very interesting setup. Working with smartphones, well, we have definitely encountered problems with the difference in the different smartphones. So can you comment on that?
You mean about, like, how we can improve our setup?
No,
many cell phones?
I mean, do you need to have a specific smartphone for and camera different? Everything is got so
Yeah,
different.
everything
for-
is different.
Yeah.
So we develop our biosensor with one specific phone because we had 9 months to develop one.
Yeah.
But it's quite easy to just adapt the geometry of this part here to adapt it to the cell phone you want. So basically, the main things I would change is the distance between the camera and the light. And
So yeah, so what you're saying is that you actually need to develop for the specific phone each time, also for a new model and all that.
yeah, indeed.
I mean, this is something we come up. I mean, it's a known problem.
Yeah.
Yes. Okay. But I mean, excellent. Thank you.
Well, I feel like there might be a different design that could be possible to be able to adapt it to multiple phones and not just have to reprint it. But
Yeah.
we were thinking at one point about like a clip-on thing that could be adjusted.
But the problem is that they put the light sources different places.
Yeah.
On the
Yeah, I
phone, and
Yeah.
they do, they
Yeah.
don't comply at all.
No,
No.
and now you have
Really
3
annoying.
And
cameras
even
and
just the intensity of
I
the lights
know,
is
yes.
It's quite a
extremely. We
challenge,
tried
yeah.
one time, because with my phone, I have an iPhone, and the intensity of the flash is like a tenth of the intensity of an Android. It was,
Yeah.
yeah.
It's very annoying.
Yeah, we had issue with that, but it's alive.
But great work anyhow.
Thank you.
In the same light of this discussion, I think it's also interesting to take some regulation into account if you want to take different mobile phones and to make them adaptable. I think that would be a real challenge to manage that. Good luck.
Thank you.
Well, we also want to minimize the sample manipulation. Right
Yeah.
now, the having to inject and doing the suction is because we didn't get to the point of implementing a capillarity system, but it's already ongoing. We have our partner who is really excited about it, so it's really fun to have people who are so motivated to help us. And ideally we want to do that, and then maybe also add microfiltration system to be able to do whole blood and eliminate the blood cells before it gets to the circle here where the analysis takes place. Yeah, that'd be fun.
Thank you. Very interesting presentation. And a question about your calibration curve, because you have two plots. On the left, it's the SPR calibration on a commercial SPR system, and on the right, it's on your own instrument. And I believe what you said was it looks promising.
Well, I mean, we were very satisfied with getting our 0.92 at that point. It was the first test we did, but
Yeah.
we continued working afterwards to produce triplicates.
Yeah.
We just couldn't include it in this presentation.
Yeah.
And also, well, on that, there's two plots because one was functionalized the day before. And we'd also like to try maybe storing them for even longer, a week, 2 weeks, and see what happens. So far, for the orange line there, they were functionalized 24 hours before and conserved in PBS at 4 degrees. And it worked very well.
Mm-hmm.
Well,
Yeah.
I mean, it worked well for
No,
viewers.
I'm commenting a bit on the fact that in the right curve you say I'm quite happy with an R square of 0.91, but on the other hand, if I look to the calibration curve, I can also say that between 0 and 3 or 4 milligrams per liter, your signal is identical. So it's be a bit careful with that. Yeah.
Oh yeah, well we need to do way more tests
And also I can comment on that with the fact that we do pixel shift, and so right now we're not using any lens on our device, but by hiding a lens we would get a better resolution, and so probably that inside this region we would get a better precision.
Yeah, the rainbow itself takes about like a tiny little square on the screen. So if we could add a lens to zoom in, it could allow us to have like you said, better resolution. Because sometimes if you, from one pixel to the next for here can mean a lot. Whereas if we had a zoom, we could kind of spread it out a bit more. I don't know how to explain it, but
you would get a better optical resolution.